Okay, so one of the things is that we need to talk about, first of all, is the different type of microphones. They're all transducers, but they're different types. So addressing that is going to have to be addressed at what type of a transducer they are as we go from microphone to microphone. But before we get started, I think it would be very pertinent if we try to address some of the general issues that are going to be directly related to any type of microphone that we're using. There's going to be some things that are going to be, no matter what type of microphone you're using, there's going to be things that you're going to have to take into consideration in general, no matter what type of transducer you decide to use. So let's take a look at some of those. All right, the first thing we're going to understand is almost anything that we generalize for all microphones is going to be, it's kind of hard because even if we generalize it, that basically that, condenser microphone and that dynamic microphone might have those same issues. Take, for example, the noise floor. That's a general issue, but they both might be dealing with those issues differently, or you have to address those issues differently with those microphones. So as we talk about these things, that, we can only get so in depth on it without actually applying the concept to a specific type of microphone to really understand what's happening in that specific instrument. But we're going to approach those concepts anyway, and there's no doubt that we'll have to readdress them again as we address the specific type of microphones. So let's just talk about that real quick. The first thing that we'd be talking about is what? You could start anywhere, but what things like frequency or impulse responses. How the microphone's going to capture the impulse responses, early and late reflections and reverberations, acoustics of the room. That's something we are most definitely going to have to talk about. And the other thing is going to be what? Something like polar fields. The polar field of, the microphone, how it captures and what its polar field are. Is it cardioid, hypercardioid, what is it? What type of microphone is it? That's something we're going to have to address. We're going to have to address proximity effect, that you get closer to the microphone and it starts boosting bass frequencies. That's something we're most definitely going to have to talk a little bit about that. Power supplies, phantom power, whether or not it's got a battery in it, and how that might affect the signal. That's something we're going to have to address. The noise floor itself, we're going to have to address that. The dynamic range and how that's stated, how they address that concept so that you can understand what they're talking about. Phase issues. Phase issues can be a huge problem. Sometimes they might be no problem at all, but sometimes they might, if you're got some type of phase issue happening inside the microphone, that it may not be causing a nonlinearity, but a phase issue that it might not affect the sound, but it might, depending, that may depend. So it's something we should talk about. The frequency response. There's another huge thing that we need to talk about, frequency responses, and we understand some of general idea of a lot of these things, and if you've watched all those videos, maybe a really good understanding of these. But the frequency response, and one thing about the frequency response is, as the frequency response, does what it does, and you get actual frequency response, that, in some of these areas, it might be resonating and causing other harmonics in the actual frequency response. So that's something we have to talk about. Impedance, inside of the electrical circuit. We're just trying to deal with the actual instrument itself, but the impedance inside of it, how's it, like a resistor is slowing things down or impeding, the signal and what that might be doing to it. Signal flow. That's a huge thing that we need to take in consideration, because you can be dealing with the signal flow just inside the microphone itself, because the signal flow starts out here with the sound the microphone's trying to capture and goes all the way through, till it comes out the microphone. So there's signal flow there that we have to deal with. And we can be talking about the actual transducer, and we can be talking about signal flow that's farther on the innards of the microphone that might be turning it into a digital signal, or it might be running through resistors or capacitors, and I don't know what all in some certain microphone doing some certain type of thing. There's a reason why they all come out with different colorations, saturations, and those things. Something is different in the microphone to cause that to happen. Otherwise, they would be no different. So that's something we need to take into consideration. The other thing is going to be the equal loudness contour. The equal loudness contour is directly related to the frequency response. If you've got a flat response, or you've got a frequency response that isn't flat, and is it shaped like, is the frequency response going to react like the equal loudness contour so that the microphone captures the sound like your ear hears it, or is it capturing it some other way? That's a huge thing we have to talk about. And, distortion and noise. Those are two types of saturation, because normally in a microphone, you're not dealing with actual distortion. You're dealing with what they refer to as saturation, which basically works out to some type of distortion and some type of noise. So, and that can also happen if you're overdriving the amperage capabilities of the microphone. Nowadays, it's not real likely that you're going to be overdriving the speed capabilities of the circuit, but in an older microphone, it might be, and that might be what colors the sound. So you're trying to get this mic sound from this old microphone that's got this great saturation and can't understand that their circuits back then sucked. And so, you basically get this saturation. If you can get it under control, it actually adds this nice hue to the sound, like a nice little bit of blue on there, and that can be very pertinent because it can. There's no doubt about it. If you can control saturation, noise, and distortion, it's a huge tool. And if you went back and watched those videos, that you already understand that. So those are just some of the basic things that we want to address, and what we're going to do is we're going to make a few short videos trying to address those issues generally. It's really hard to say, well, some of these issues, trying to address them when, they're going to be being affected differently or have a different effect, on this condenser microphone, or this piezoelectric microphone, or, this dynamic microphone, but we want to just address them in general. And, just so we understand what we're looking at, how the actual industry might look at some of those concepts, so that when we're trying to understand how those concepts are being addressed when we're looking at some specific microphone, that we have some understanding of how they might have worded it, or what type of structure, or what kind of system they're dealing with that, so that we're better able to address those things. One thing that I wanted to talk about is I got into looking at diaphragms on microphones, and some of the material that they use on them. And it was really hard because some of the things we're going to run into are going to be trade secrets. So we were going to run into the type of magnet, the components, how the magnet was built, the diaphragm material, the mylar, how the mylar was mixed, what they might have put in it, that they sometimes don't want to tell you nothing about it. So it's really hard to make an informed decision about the mylar that they used for the diaphragm when you're looking at the microphone construction, because they don't want to tell you nothing about it, because they don't want Bob to know. So Bob can copy their microphone, and and then you don't buy their microphone. So that's something that we have to try to address those issues as well as we can, from, in a way to try to understand how the issues that, the difference in the thickness or the type of mylar or the mixture, as an example, what kind of things is that going to cause? So that, when we're looking at Bob and Timmy's microphone, that we can go, well, no matter what his mixture was, I'm having an issue with his impulse, with the impulse response that I'm getting, and I don't know how he mixed his mylar, but that's an issue, and it might be that, or it might be the magnet, it might be the inductor, the inductor material that they used in the coil in the dynamic mic, in the dynamic mic, but I don't know for sure, but I can look at what's happening to the signal and get a pretty good idea that something in there ain't right, so I don't want that microphone because it ain't going to work correctly and to do what I want it to do. So that's a really hard thing to approach. We're going to try to, but I don't want to make 500 videos on, understanding, the different mixtures of mylar. but we'll address it, or the different mixtures of a magnet, and how he got, a whole box of them, or 50 pallets of them for, 99 cents a piece rather than $1.50, and so we got a lame microphone because he got a great deal on, which can happen, but how are you going to know for sure is very difficult without having that information. So some of those issues we just have to kind of go, well, it's debatable, what might have been happening there. So I'm not really sure exactly yet how we're going to approach that issue, but I have no doubt in this series that eventually that we're going to have to. So that's what we're going to do. So in the videos that you watch after this one, we're going to be going through each one of these things that we just talked about, the general issues, and we're going to address them in hopefully short videos, but concise videos, but well-informed videos, which is going to, depend on how long they are, but we're going to try to address all those issues before we actually get into the specific type of microphones. Then we will address, dynamic microphones, and all the other type of microphones that we might be dealing with. So let's get started. See you in the next video. Peace, hope, love.